So it says the objects described by a set of data are called individuals. There's a lot of vocabulary here that we need to define first. Individuals may be people, animals, or things. Any characteristic of an individual is called, it's called a variable. So this can take different values from different individuals. So we have two different types of variables. Okay. First type is called a categorical variable. Categorical variables place an individual into one of several groups or categories. So for example, what class are you in? Freshman, sophomore, junior, senior. That is a categorical variable. All right. Any variable that you can put into categories, okay, is a categorical variable. On the other hand, we have a quantitative variable. It takes numerical values for which it makes sense to find an average. If it doesn't make sense to find the average, then it is probably categorical. Not every variable that takes number values is quantitative. So think about zip codes. They are numbers, but it doesn't make sense to find the average of a zip code. Therefore, it's probably categorical. Okay, so if you can find the average of a certain type of variable, then it is quantitative. So your GPA, for example, is a quantitative variable. What class you are in, as I said, is a categorical variable. Could be within quantitative variables, we can break it down further, all right, which we will look at. All right, I'll go ahead and write it here. There is discrete. So a discrete quantitative variable are counts, something that it makes sense to count, the number of calculators that I have, okay? It doesn't make sense to talk about half a calculator, all right? And then there's another. Anybody want to take a guess? We have discrete and no. It's a nice guess. Continuous. Okay. A continuous quantitative variable can take on any values in its domain. Okay, so discrete are counts, number of people in this room, for example. Continuous can take on any value in the domain. So let's look at this little coaster craze. Do you like roller coasters? Newhouse. In the past, like roller coaster, there's nothing like, right? Hands in the air, wind blowing through your hair, right? Riding that little roller coaster. So it may be kind of hard to see on the copy of your notes, but there's a highlighted row there. The coaster craze. Many people like to ride roller coasters. Amusement parks try to increase attendance by building exciting new coasters. The following table displays data on several roller coasters that were opened in a recent year. Okay, so part A says, what individuals does this data set describe? Well, roller coasters. That were opened in a recent year. Okay, and so stats math is a little different. Context is really important. You're gonna have to write a little bit more than you're probably used to in other math classes, okay? But it is really, really important. People lose points all the time on the AP exam for being lazy and not putting things in context. Okay, so really want to emphasize that. Put things in context. Write in complete sentences. All right. So what are the individuals? Roller coasters that were opened in a recent year. What variables were measured? Okay, well, there's several. We have type, height, just following the columns there. Design, speed, and duration. Let me scroll up there. Okay, identify which variables are categorical. Tell me, please. Oh, Joseph, which ones are categorical? Okay, I would agree with that. Type, design. Both of those variables are types of categories, right? And so the other three have numbers, right? So they are going to be quantitative. So speed. Does it make sense to find the average speed of the roller coaster? Yes. Sure. Therefore, it is quantitative. Okay. So we got speed, we have height, and we have duration. Describe the individual in the highlighted row. Okay. And so that is the next to last row there. It's kind of hard to see on your notes, right? But this is what I was talking about when I said put things in context. Okay. And a lot of times we will get into this later, right? But the AP free response stats questions are graded on a little bit different rubric. All right. But that rubric, a lot of times, one of the important components is context. So I'm going to say, here's what I say. The roller coaster is the prowler. A wood sit-down type coaster. Its height is its height is 102.3 feet. Its speed is 51.2 miles per hour. And the duration is 150 seconds. Okay. Got to know your vocabulary. Okay. Individuals, the different types of variables, categorical, quantitative. All right, turn the page for me. It says the radio audience rating service Arbitron places US radio stations into different categories that describe the kinds of programs they broadcast. Here are two different tables showing the distribution of station formats in a recent year. The individuals are the radio stations, and the variable being measured is the kind of programming that each station broadcasts. The table on the left is a frequency table that shows the counts or frequencies of stations in each format category. The table on the right is a relative frequency table of the data that shows the percents of the stations in each format. Okay, so we have two different types of tables here. All right, first is called a frequency table. We have the total number of radio stations here, which is 13,838. And then it is broken down by types, categorical variable, right? And then within each of those types, it's listed the frequency, okay, the counts of how many adult contemporary radio stations there are and how many rock stations there are. Okay, whereas a relative frequency table lists the percentages. So 11.2% are adult contemporary. All right, Spanish language, 5.4%. Okay, both of those tables give helpful information, but in different formats, right? Depending on what you are looking for. There are two ways to display the distribution of a categorical variable. Okay, one, this is only for categorical variables. Okay, one is a pie chart. Each slice represents the percent for that category. So country, this slice occupies 14.9% of the pie because 14.9% of the radio stations have a country format. Okay, so that is one way. And the other way is a bar graph. All right, so bar graph, pie chart are used to display categorical variables. Right, question. Let's stop here, pause for just a second. What is the difference between a bar graph and a histogram? Which we will look at later, right? But wanted to go ahead and throw this out there. Anybody know the difference between a bar graph and a histogram? They are similar, right? Histograms also have bars, but there's a distinct difference. Avery, you want to take a guess?
The histograms go sideways.
What do you mean by that?
Like it's on the y-axis.
No, the axes are still the same. The difference is, number one, the types of variables that they measure. Okay, bar graph is only for categorical. Histogram is useful for demonstrating, showing large data sets of quantitative variables. But what I was looking for here, what do you notice about the bars in a bar graph? Don't overthink it. They are different. Are they touching? No. Why are they not touching? Well, because what are they displaying? What type of variables? They're displaying categorical variables. And so here, bars do not touch. Bars don't touch. Whereas in a histogram, they do. Okay, so we will get to that in just a second. First, I wanted to highlight this. All right. All graphs must be labeled and scaled appropriately. Okay, that is really, really important. I have had students before on their first quiz or their first test. I mean, it's just a glorious work of statistical art. It's beautiful, except they forget to label. And so they get a little nasty note from Newhouse that says, label your graphs. All right. Please take the time. You've got to scale your axes. All right. and label your graphs. Got it? All right, let's take a little stats break. I need you to stand up for me. Stand up. Let's go stretch. Let's do a little stats yoga. Right? Come on, it's early. Stretch, maybe I should bring my foam rollers up here, right? Tammy, we can roll out in the morning, stretch a little bit, get the blood flowing. We're gonna do a little bit more today. Kind of like stick our big toe into the stats pool, right? See how it's going. All right, sit back down for me. All right, cell phones. The Pew Research Center asked a random sample of 2024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other, including non-smartphones. Here are the results broken down by age category, okay? And so the first thing that we notice, this is from 2013, okay? That's probably important because that was, relatively speaking, a long time ago for you all, right? 11 years ago. But we're looking at a snapshot within this window from 2013, okay? So it's broken down here, and we call this a two-way table. Because it describes two categorical variables. The first is age, and the second is cell phone type. Cell phone type is the row variable and age is the column variable. The entries in the table are the counts on individuals in each cell phone type age class. All right, and so this next definition is important. It is called a marginal distribution. A marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values that variable among all individuals described by the table. Okay. So marginal distributions, I kind of like to write me a little note because it helps me think about it. Marginal distribution, you're looking at the totals. And I think it will make sense in just a second when I do an example. All right. So it says use the cell phone data to calculate the marginal distribution in percents of type of cell phone. All right. So look at the table. How many total iPhones are there? 467. Out of how many total cell phones? 2024. Okay, so use your calculator, find that percentage. Just quickly, okay, 23.1%. Okay, so Android, again, finding the marginal distribution, the totals. How many total Android phones? Look at the table, right? And the column right here. Okay, so there's 503 out of a total of 2024. So we got 503 divided by 2024. And so I got approximately 24.9%. And then the other, there were a lot of others back then in 2013, right? These numbers would change, obviously, if we did another sample. Okay, which is something, I'll bring this up now, right? But we can talk about it right now. Context matters. Where did they take the sample from? Adults. When did they take the sample? Right? 2013, which was a little bit of time ago. If we were to do another sample, and we'll talk about how to sample later on in the course, right? We might get slightly different results, right? But the total here, it was 1,054 divided by 2024, which is approximately 52.1%. Okay, so part B says, make a graph to display the marginal distribution and describe what you see. Okay, so I can either use bar graph or a pie chart. I'm going to use a bar graph. Ten, 20, 30, 40, 50, 60, 70, 80, 100. Okay, and so what is my y-axis? These are percentages. All right, and so down here, I'm gonna make a bar chart. The iPhone was 23.1. And the Android was 24. And the other was 52.1. What's wrong with this? Label it, right? So this was iPhone, Android, and other. And then also follow the directions, right? It says, describe what you see. So what do you notice? And you don't have to overthink this, right? But I said, at that time, the iPhone and the Android, they were about the same, right? But the others were what? How do the others percentage-wise compare to the other two? They're almost double, right? So I said the percentage who own an iPhone or Android is about the same. But more than 1/2 do not have an iPhone or Android. Okay, so one more little thing here, and then we will call it a day, all right? So we have a marginal distribution, which looks at the totals. And then we also have what is called a conditional distribution. So a conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. There is a separate conditional distribution for each value of the other variable. Okay, so It says calculate the conditional distribution of cell phone types among those in the 18 to 34 age class. And repeat for those in the 35 to 54 age class, and also for those in the 55 plus age class. Okay, so conditional distribution of cell phone type for 18 to 34. All right, so turn back to the table there. That means we are looking only at the 18 to 34 column. So I got to get back there. We are looking at this right here. And the reason that I'm only looking at that column is because, okay, it says the conditional distribution of cell phone type for 18 to 34. So how many iPhone users were 18 to 34? There were 169 out of a total of 517 18 to 34-year-olds. And that percentage was 32.7%. Okay, how many Android users were 18 to 34? 214. Again, out of a total of 517. So that is 41.4. And then the others were 134 out of 517, which is 25.9%. Okay, so now what I want you to do, go ahead and fill in these columns. Do the conditional distribution of cell phone type for the 35 to 54 and the 55 plus. Okay, check your numbers with mine. All good. Question for me? Yes. We're kind of relaxed about that in stats, okay? So the answer to your question is no, not necessarily. In calculus, they want you to go to 3 decimal places. In stats, they're more like, yeah, okay. Close enough, looks good. So there's no, to answer your question, there's no fixed rule, okay? All right, well, tell me one thing that you notice from the data. Okay, so stats, I said yesterday, we collect data and then we analyze it. So now that we have some data, what's one thing that you notice? Look at the 55 plus and the other. How much higher is that than an iPhone or an Android? right? Why do you think that is? Because old people have trouble, right? With smartphones. I still remember my father trying to show his mother, my grandmother, right? Just how to use a cell phone, a regular cell phone, and it was a complete and total disaster. Okay? Questions for me? Last thing here, okay, but we won't do this now, but I just wanted to introduce it. There are two sets of conditional distributions for any two-way table. There's one for the column and one for the row. So the conditional distribution of age, given that it is an iPhone, we're gonna be going across the table this time, but I'm going to leave that for next time and we will pick that back up here. Okay, so